In this video, we are going to go over a very simple contact analysis for MSC Nastran. Now, we have two cubes coming into contact. This bottom cube is fixed at the base, and this top cube is fixed at the top face. If you look closely here, there is a distributed load. Now, this is what the deformation looks like with no contact. You can see that the top cube is going completely through the bottom cube, and the bottom cube is not deforming at all. But when we define contact, this is what the final outcome looks like. You can see the top cube is actually coming into contact and deforming the bottom cube. So that's the goal for today's video, how to define contact for MSC Nastran. Now, you'll notice that we are going to do this all in a web browser. We are going to be using a web application for today's exercise. If you want access to this web application, you can go to theengineeringlab.com. Here in the top right hand corner, you would go ahead and click on free trial or the blue button, fill out the form, and then you'll get access to today's web application so you can go ahead and follow along with today's exercise. Now, this is what I have for the agenda. We are going to go ahead and actually define the contact bodies and the contact pairs, and then I'm going to show you 3 different ways to perform the contact analysis. Method 1 is going to be the node to segment contact. Method 2 is going to be the segment to segment contact, and then the third method is going to be the permanent glue approach. Okay, so I am assuming that you have a bulk data file of the cubes. You've already gone and meshed, you've already loaded, defined your materials, you've already attempted, or you've already successfully performed a linear statics analysis in this case. So this is going to be the starting point. So once you get access to the web app, you come here to the home page. On the far right, you click on the viewer. Let's go ahead and take that bulk data file and let's import it to the web application. So you notice that we have the same queues, we have the same boundary conditions and loads, and now we're ready to define some contact definitions. In this other window, I have a diagram that hopefully makes contact analysis a little easier to understand. Now, for each meshed body that you want to come into contact with one another, let me do this. Let me do this here. Suppose you have 3 meshed bodies like you see on the screen. For each mesh body that you want involved in the contact analysis, you have to define what's called a BC body 1 entry. Since in this contact analysis we have 3 contact bodies, we need to define 3 BC body 1 entries. Then for each BC body 1, you have the option of defining a BCB DPRP entry. This is going to let you define information like friction. If the contact bodies have a coefficient of friction, you would come into a BCB DPRP entry and you would define it there. Now, for each contact interaction, you define what's called a contact pair, and you do that with the bconnect entry. And then associated with the bconnect entry, you define what's called a bcomprg entry. Here you could define different things like the contact distance or the error. So this value, the error value, this is very important. This is going to define a contact tolerance, a distance tolerance. It basically determines the distance at which the contact pairs are deemed within let me explain it again. When 2 contact bodies are within a certain distance, if it's within the error distance, it's deemed as contact. If the contact bodies are outside of that distance, then no contact is detected. And then you have other values like the iGlue option and the iSearch option that you'll see me use throughout this example. Here, since we want these two bodies to come into contact and these two bodies to come into contact, we'll define two B connect entries. Now, when you have different load cases, then you have to go ahead and assign these contact pairs to different subcases. The way you're going to do this is as follows. For each subcase, you define what's called a B contact command. That is then going to point to a BC table entry. That BC table entry is going to contain all of the contact pairs. So here in this example, if it was this diagram here, you have two B connect entries that are used by this BC table 1 entry, and then the B contact entry points to that BC table. So all of this is an overview, and now let's go ahead and actually define all of this for the cube. So let's go ahead and do this. Let's go ahead and define our BC body 1 entries. Let's define our deformable bodies. So here we have to first define what's called a BC prop. So that would be this entry. Let's go ahead and create 2 rows here. For this first BC prop, we'll go ahead and select the bottom cube. So you'll notice it turns yellow. And then for the second BC prop, we'll go ahead and select the top cube. And then whenever you make a modification here on the right, it's updated on the left. And the respective bulk data entries are also updated for you here on the right side of the window. Okay, let's go ahead and now create our deformable bodies with a BC body 1 entry. So use the BC body 1 entry, open that, create an entry, and create a second entry since we're creating 2 deformable bodies. For the dim field, or actually each input that you see here, if you click on display descriptions, this will give you more information as to what each entry is. And then one thing I forgot to mention, I am assuming that you have gone to the nonlinear users guide, you have gone to this chapter contact, and you've already taken the time to read the documentation. All of the concepts I'm describing here are covered in great detail in this documentation. I'm not going to go into very good and great detail because this video would easily be 10 hours of discussion. No. I'm assuming you've already gone through this. You're already familiar with a lot of the concepts. And now here we're just putting it together in this video. So for the dim field, let's go ahead and set this as a 3-dimensional scenario. For the behavior, these are going to be deformable bodies. For BSID, we're going to select the BC prop entries that we defined a moment ago. So here what we're saying is take every element associated with this property and assign it to the first deformable body. And then for the second deformable body, we said take all the elements associated with this property, P solid 2, and associate it with the second deformable body. So we're at this point. We have defined, here, let me delete some of this. We have defined 2 contact bodies, 2 deformable bodies. Now, there's no interaction with these 2 bodies. So that's when we define a B connect entry. So let's go ahead and undo this. So this is what the, let me take a step back here. So now we have to define this contact interaction, this contact pair between both deformable bodies. So how do we do that? We go back to this section and we look for B connect. And we'll go ahead and select this and we'll click on create entry. And then here, let's go ahead and look for ID second. Let's go ahead and select the first deformable body. And then for ID prim, we'll go ahead and select the second deformable body. Let me look at my notes and see if I'm forgetting anything here. No, for now, let's leave that as is. Let's go ahead and close this. Now, we have defined our deformable bodies. We defined some contact interactions or contact pairs. And now we need to go to our load cases or subcases And now we have to define this configuration here. We have to tell the load cases, hey, use these contact pairs, use these contact bodies I've defined. So first, we need to define the BC table 1 entry. So let's go and look for BC table. Use BC table 1. Click create and say thus. We'll just define one contact table. Say take those contact pairs and put them in this contact table. So you'll notice here on the right, I've selected bconnect1. I've selected that contact pair. And now for the case control command section, go to the command section, look for bcontact, select subcase 1. So we're saying turn on contact for subcase 1 and point to BC table 1. So we've turned on contact. We're saying use those contact pairs. And now let's try and run our first Nastran analysis. Or rather, let's try and run our first contact analysis. And now let's look at the deformations. So one big recommendation I make is when you look at the deformations in a contact analysis, always use a scale factor of 1. By default, many programs will use a scale factor of 100 or 10 or 0.1. Here, always make sure the scale factor is 1. And so here is the first set of results from our contact analysis. So this is before deformation and then after deformation. So the cube on the top is actually coming into contact with the bottom cube and deforming it. But then this shows us the first problem in this analysis. What was previously a flat surface, so you can see this cube face was previously flat, it's now jagged. It's sort of spiked, if you will. This is a very common issue when you're using node to segment contact. There is actually a section devoted to this, so let's go ahead and look for pore. So if you come to the documentation, there's a section called example of pore body numbering. This goes into great detail regarding why this happens, and I'm going to save you the discussion here and just show you how to address this. The easiest way to address this is by doing the following. If you define what's called a bcon PRG entry, so here, if we zoom out in this diagram, for the contact interaction of the contact pair, we're going to define what's called a bcon PRG entry, and we're going to use what's called the iSearch method. So let's go ahead and do that. So let's go back to pre, to bulk, to select entry, and let's look for bcon PRG. Select the first row, create entry, add row, and let's go ahead and select iSearch. And the magic number, the magic option you want to use is number 2. And now let's go ahead and go back to the bconnect entry. And let's go ahead and associate that bcon PRG. So this contact pair is now using the iSearch 2 option. And let's rerun this analysis. So again, this is covered in great detail in the documentation. The goal of this video is not to cover every detail in the documentation. No, the goal is to show you what the procedure is like, what the process is like for defining all these different settings. And then if we look at the new deformation, you'll see that the face of this cube is smoother than it was before. Let's rotate this model a little. Let's go ahead and turn off and on the deformation. And now let me do a recap of what we did. So here, let's go ahead and open the OBC's display panel. Or first, let me hide the coloring of the faces. And let me go to OBC's. So first, we defined deformable body 1, which was this body. And then we define deformable body 2, which is this body here. Now, what you see on the screen right now are representations of the contact analysis. It's not to be interpret it literally. They're not literal spheres that are coming into contact. No, these are just placeholders. They're icons. They're symbols representing the contact. Here we define a contact body 1 at the bottom that use BC prop 1, and then at the top we have a second deformable body that's pointing to BC prop 2. And then in between these contact bodies, we defined a contact pair B connect 1. So if you want to look at the actual contact bodies, let's go ahead and turn on the faces. And here in these checkboxes, you can turn on contact body 1 and then contact body 2, like you see here. Okay, now where are we at with the agenda now? So we just use the default contact method, which is known as node to segment contact. Let's go to now switch to segment contact. So let's go ahead and do this. Let's turn off iSearch. And let's rerun the analysis. So if you remember, when we had iSearch equals 2 off, we had this very rough surface to one of the deformable bodies. So you can see it's jagged, it's kind of spiked. The alternative to using iSearch 2 is to switch and use what's called segment to segment contact. So let's look for BC para. Let's create an entry and add row. Let's go ahead and look for method. And let's turn on segment to segment contact. And now when you rerun the analysis, it now switches to using segment to segment contact. And you notice that the face of the deformable body, it's smooth and in this case flat. So if we look at load case 2, which is not using contact, this is what that looks like. The top cube is going straight through the bottom cube, and you see the bottom cube is not even deforming. So this is without contact. Subcase 1 has contact on because we defined that B contact command. And you can see that the top cube is actually coming into contact with the bottom cube, and it's deforming the bottom cube. So that's how you define a contact analysis with segment to segment contact. And now for the last type of contact is with permanent glue. So let's go ahead and turn on permanent glue. If you look back at this diagram, permanent glue is turned on by defining that value in the bCompRG property or entry. So that would be the iGlue option here. So let's go ahead and look for bCompRG. bCompRG, that would be this option. Let's go ahead and turn on iGlue, and we turn iGlue on with a non-zero value. So in this case we'll use 4 since that is the most common approach, or rather 4 is the most common option. So let's go ahead and rerun this analysis, and here I expect there to be an error, and if we read the error carefully, typically when you ever see an error, you want to read the first line and the next 3 to 5 lines. If you read the error closely, rather, you'll see that permanent glue is on, but no nodes were found to be glued. So what's going on here is the following. Let me exit this. One of the contact bodies is so far away that contact is not being detected. So what you want to do is you want to define a contact distance. So let me see if I can show you with a quick diagram here. So I'll use maybe red for this, or orange. Here, let me draw a diagram here that's going to represent the contact distance. And then we'll add little dashes to indicate this is a distance here. So here you'll find many people using various terms for this contact distance. Sometimes I'll refer to this as the gap. Nastran calls it the error. So there are various names that this is given. You want Nastran to recognize that this gap is contact. So the way you do that is with the error value. So here, if you look at the bottom right, you want to go back to that bcomprg entry. You want to define an error. So first, what is that gap? What is that distance? So let's go ahead and find out what the distance is. So let's go to the fem label tool. We'll go ahead and select maybe these two nodes. Now this is going to give us an approximation. It's not going to. So we'll go ahead and select this node and this bottom node. And then we'll go ahead and display the distance. So the gap is approximately 0.1. So what I can do now, I can go to the bcomprg entry. I can define an error value. So here we're going to say if the nodes are within a value of 0.11, then we deem those nodes as being in contact with one another. So we'll use 0.11. Here, since we're using segment-to-segment contact, it's not nodes that are coming into contact, or we're using invisible segments, if you will. The segments are not visible to you, but it's using segments internally to detect contact. We're saying here, if the segments are within a distance of 0.11, if this was units of meters, that's 0.11 meters. Use that to detect contact. Here, we're using glue. We are defining glue between these two cubes. And so this is what it looks like after that successful analysis with permanent glue on. So this is before contact and after, or before loading and then after loading. One contrast, one difference between the previous contact analysis and this analysis is that since we're using permanent glue, we are preserving that gap that we had before, but we are still deforming. This top cube is still coming, or since there's a glue defined between these two cubes, whatever happens to the top cube is also happening to the bottom cube. So this is the deformation that you see here. Okay, so that is pretty much it. Let me conclude this video with a few remarks. So we went through this diagram and we defined, in this case, we had two contact bodies. So we defined one contact body and then a second contact body. And then we defined a contact interaction, a contact pair, and we did this with BC body 1 to define the contact bodies, and then B connect to define the contact interaction. And then we played with a few options. We played with the iSearch option. We played with the iGlue option. We played with the error option also. So there's a lot we did here. This diagram is probably going to be a good diagram if you're a new user of contact analysis with Nastran. We took a look at 3 different contact options. We used a node to segment contact option, the segment to segment contact option, and then we switched, and instead of using the traditional contact approach, we use the permanent glue option. What happens when you glue those two cubes together? So that's pretty much the end of this video. If you do have a question or comment regarding contact analysis, here's my email address. Feel free to send me an email, and then I'll try and get back to you as soon as possible. And so there you have it. That's how you go ahead and configure a contact analysis with MSC Nastran.